You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. Post bits are there means you can simply deduct the 8 bits from the 32 bits. Okay, which means 32 minus 8, you will get 24 bits for your post portion. Okay, so by finding the slash notation, which is called as a CIDR, classless interdomain routing, or we can call it sometimes as subnet mask. Okay, so slash 8 represents number of your network bits. So from that, if you deduct it from 32, you will find number of host bits. Okay, so here we have found that 32 minus 8 is 24. So 2 to the power 24 is hosts in each subnet. Okay, so from each and every network in this address, you can have around 2 to the power 24 hosts. Okay, not only for one network, for each and everything separately you can have 2 to the power 24 hosts. So it looks like, for example, let's say if you are having 2 switches which representing the network means few amount of networks with more PCs, more hosts, okay, more end devices, printers, servers, IP phones, whatever. Then we can move for the class B, which means slash 16. Again, you know, first 2 octets representing the N and the remaining we wrote with H. Then 2 to the power 16 bits representing the network. So 2 to the power 16 bits of network you can have in this subnet. Then to find the host bit, you can simply deduct it from the 32 so that you can get the 32 minus 16 equals 16. So simply you can get 16 bits of hosts on each subnet. Okay, not only for one subnet, for each of the subnet you can have around 2 to the power 16 network devices. Here also 2 to the power 16 network devices. Here also 2 to the power 16 devices. Likewise, for the switches, you can again, since it's a class B, you can have again 2 to the power 16 switches. Okay, for example, I'm saying. So likewise, when we go for the class C slash 24, which is represented as n.n.n.h, which means the 24 bits given for the network portion and the remaining 8 bits given for the host portion. Okay, so here you can have around 2 to the power 24 networks. For example, let's say if you consider the networks as switches, you can simply imagine you can have around 2 to the power 24 switches connected, and each switch can have around 2 to the power 8 hosts, which means 256 PCs on all networks. On each network you can have around 256 PCs connected. Okay, so each PC connected to the switch can communicate with their neighbor switches, okay, which are connected to the same switch, not to the other switches. Okay, for example, let's say if you are having a requirement of increment in your network from class A, which means from slash A, if you wanted to increase your network, you can do is you can go for the class B. So what you will do, simply from class A you will change your slash 8 into slash 16. By doing this, what is the result? Your network is increasing considerably. At the same time, your host requirements are getting reduced. Okay, for example, if you move from class A to class B, your network will increase. 2 to the power 16 networks you can have, but at the same time, earlier you had 2 to the power 24 hosts in class A, but now after changing to class B, you will have only 2 to the power 16 hosts in each subnet. So this is a problem for us when it comes for the network design. We can't waste the IP addresses, right? So if you keep this much of network change, then if you assign the network addresses to each switches, some of the networks which might not have that much of PCs,